Obviously, we take measurements every day. What are we measuring? We are measuring different physical parameters, physical quantities. Now, it is very essential for us to classify these things that we are measuring. Now, one of the very way of classifying quantities, physical variables, is using scalar and vector. Now, being the first video in this playlist, you are going to learn the introduction to vector, the very thing that you need to understand as far as vector and scalars is concerned. So what are the previous knowledge that you must have to get this understanding very quickly in order to help you while dealing with the calculation aspect of vector? The first thing is you must know Euclidean geometry very well. I have the playlist, watch them. You must know trigonometry very well. I have the playlist, watch them, and coordinate geometry as well. Without further ado, let's start the lecture. So when we talk about scalar quantities, they are quantities that have size, they have magnitude or numerical value. You can measure it, you can quantify them. When you are defining scalar quantities, the only thing that you are using to define them is you are just using how big, how enormous they are when you measure it. You don't need to provide any other thing again. So example is temperature, distance, energy, and so on. Scalar follows the basic arithmetic rules such as addition, subtraction, multiplication, and division. So when you are talking about scalar quantities, when you want to add them together, you just add them together. Like you are adding 2 plus 2 is equals to 4, 3 plus 3 is equals to 6, 10 plus 20 is equals to 30. Now the same way we had in mathematics, in arithmetics, that is the same way we add scalar quantities together. For instance, 10 degrees Celsius plus another 10 degrees Celsius, when you add them together, you get 20 degrees Celsius. So for scalar, they follow basic arithmetic rules. Now we have another quantities again, type of quantities, which are called vector. So we call them vectors. Now vectors are quantities that are defined by size and direction of operation. So let me break it down. Recall that scalar, the only defining thing about scalar quantities is the size. And when it comes to vector, you are not talking about the size alone. You are talking about the orientation, the direction of action of that quantities that you measure. Let's take for instance force. Now force has direction. You don't talk about the magnitude of force alone, the numerical value of force alone. Force will have a defining orientation. It is going to act along a direction. So any quantities that you are using two different things, such as you are using the magnitude, the size, and the orientation of the quantity, the direction of the quantity, we call such quantities vector quantities. Unlike scalar quantities, the only defining things about scalar quantity is the magnitude. For vector, you are going to provide two things, because two vectors can have the same magnitude and they are different. You can pull something with 10 Newton force. You can also push that thing with 10 Newton force. The two forces have the same magnitude. Their effects are different. I have scalar quantities, scalar, and I also have here vector. First quantity that I'm showing here that is scalar is distance, e.g. 100 kilometers, 10,000 miles. Now we have speed. The units, meter per second, 10 meter per second, 20 kilometers per second. So speed, distance, mass, energy, they are scalar quantities. We have many of them. Now, for you to understand scalar quantity, when you are given any question and they ask you which of the following is not an example of scalar quantities, now you need to focus on vector. So when you focus on vector, you'll be able to answer it. You don't need to cram anything. Let me give you a trick here. Let's come to the vector side. Now, since vector has orientation, direction, and direction means it is going to have a point of action. Now the first vector quantity is displacement. Now master displacement and master force. When you master displacement and force, you are going to know all the vector quantities that we have. Now the first one is displacement, 100 kilometer due east. Now let's compare and contrast here. Here I'm just giving magnitude alone. Don't forget that this one is just a unit. I'm giving the magnitude. Now when it comes to displacement, example 100 kilometer due east. Now this due east is showing the direction. So if I write 100 kilometer alone, what I'm showing you is I'm talking about the distance. But when I add this due east, is showing the direction. 100 kilometer due east is different from 100 kilometer due north. Now we have another thing again, velocity. Example 10 meter per second, north 20 degree west. Now this is showing you the direction of the velocity, north 20 degree west. This is bearing. Now we have another thing again, force. E.g., for example, 10 Newton vertically downward. Vertically downward is showing you the direction. Now 10 Newton vertically upward is different from 10 Newton vertically downward. That is what I'm showing you here. Now let's compare and contrast again. Distance. If you look at the unit, it's still the same thing as the unit of displacement, but they are different. Speed, the unit is still the same thing as the unit of velocity. So speed, scalar, velocity, vector. Distance, scalar, displacement, vector. Now when it comes to mass, look at mass. 5 kilogram, look at force, Newton. Now look at energy again. Now let's look at this energy closely. We have energy, example 1000 kilojoules, and we have moment. Now let me quickly explain this. The units of energy and moment, they are almost the same, but the concept is different. Moment has a direction, e.g. 10 Newton meter clockwisely. For mechanical energy, this joules here is still Newton meter, but they are different. Energy is scalar, moment is vector. So how do you now know vector quantities? It's quite simple. Any quantity that has displacement in it, when you break down that derived quantity and you have displacement in it, definitely that quantity becomes a vector quantity. Let's see. Impulse, force times time. And if you look at force closely, when we talk about moment is force times perpendicular distance. That force is already vector quantity. That is what makes moment a vector quantity. Momentum, mass times velocity. The velocity there is already vector quantity, so that makes momentum a vector quantity. Pressure, force times distance. The force there is already vector quantity. Pressure becomes a vector quantity. Acceleration, change of velocity with time. Velocity is already a vector quantity, so that makes acceleration a vector quantity. Now if you trace all the vector quantity, when you trace them down to displacement in the analysis, dimensional analysis. So let's leave that for now.
Let's learn difference between the scalar and vector, distance, displacement, speed, velocity, and force.
Now here, let's have this key. We all know this. This one is showing us direction. So we have the north, east, west, south, northeast, southeast, south, southwest, and the likes. So let's have these two reference lines as shown here, and let's have the distance between them, which is 100 centimeter. Now on one of the line here, we have a ball as shown, and let's apply a force F to this ball. Now let's assume that this ball is going to move with a speed of 50 centimeter per second as shown. Now this ball will move from this point to this point using this speed 50 cm per second. Now let's apply another force to this ball here in this position. Now let's assume that the force that we applied here and the initial force that we applied here, they are the same. That's why I'm writing F here. Okay, now this ball is going to move with the same speed, which is 50 centimeter per second, and this ball will travel down here. Now let's differentiate speed, velocity, displacement, and distance. Now initially, recall that this ball is here, and after I apply this force F, this ball moves down here. Now the distance between these 2 points is 100 centimeter. Now again, this ball moved from this point down to this point again. The distance between them is also what? 100 centimeter. So which means that distance here doesn't have direction. It is just linear space between two different points. Now what about displacement? Displacement simply means change of position of object. Now when this ball moved from here to here, it has been displaced, moving towards the east, isn't it? The arrow is pointing towards the east, and the displacement is 100 centimeter towards the east. Can you see? Now you cannot compare it to when this ball moved from here to here, even though the distance is the same, which is 100 centimeter, but the direction is different. So which means that this is displacement. When this ball moves here to here is different from when this ball moves from here to here. So that is when we talk about vector quantity. Now let's talk about another thing here. Now this ball travels from here to here using this speed, which is 50 cm per second. And it also travels using this speed, which is 50 cm per second. Now let's look at the direction. The speed that this ball is using is pointing towards this direction, so which means that this ball is moving along this direction. So now which means that this speed will now turn to velocity, so which means towards the east, towards the right hand side, 50 cm per second towards the right hand side. That becomes a velocity. Now you cannot compare it with this one, even though they are the same, but the direction is different. So the speed the same, velocity different. Now when this ball moves from here to here, it's using 50 cm per second and moving towards the west. Now let's talk about the last one, which is the force. The force that I applied to move this ball from here to here is still the same thing as the force that I applied to move this ball from here to here, but there's one difference between them. What is that difference? Where the arrow is pointing, which is the direction. So which means that even though the magnitude of this force is still the same thing as the magnitude of this force, the two effects of this force are different. This one is pushing this ball towards this side, and this one is pushing this ball towards this side. So which means that when we apply vector, we are going to change this one to minus F. So that is vector quantities. In types of vectors, various forms of representation of vector. The first one being free vector. Now free vector is a replica of polar coordinate system. It's similar to polar coordinate system. So if you haven't watched the first video in coordinate geometry, in that video I extensively explain all the coordinate system, polar, spherical, and Cartesian coordinate system. So you can link these two together if you don't want to forget. Now, free vector is representing vector using a diagram. So not just a diagram, it is using a line with arrowhead. It's using a line with arrowhead. Now, in this type of vector, we represent the magnitude and direction of that vector using set of parallel lines of equal length. Now we are using line. The line we have length, the line we have arrowhead, and the line is going to have orientation from the horizontal plane. So the orientation is the angle, the direction. Now the length represent the magnitude. So you can draw it so far you have equal length and the orientation are the same, which means that when you have parallel lines, each of them is still the same. For instance, let's look at this diagram. We have vectors here. This is free vector. Now look at this one here. It's still the same thing as this. So if this one represents vector v, this one is also v, a line that is parallel and having equal length. This one is also v, a line that is parallel and having equal length. This one is also v, a line that is parallel and having equal length. Now it doesn't matter so far you draw a line that is having equal length and parallel, it still represents that vector you're talking about. Another type of representation of vector, types of vector, is positional vector. Now positional vector is a replica of Cartesian coordinates. Now you can liken this to Cartesian coordinates x, y, z, x, y. Now this represents vectors points of action in space, either 2D xy or 3D using some reference coordinates. Now here we are using IJK instead of using XYZ. We are using IJ instead of using XY. Now let me explain this properly. Remember your coordinate system, Cartesian coordinate system. You are representing points. Now for positional vector, you are giving the points of action of that vector. Unlike free vector that you are showing an arrow, this one is showing you the point of action of that vector, either force, either velocity, either momentum, moment. You are just showing the point of action of that vector using Cartesian coordinate system. To better understand that, we have this. Now for positional vector, you are going to get something like this. Not a diagram, so you are going to get something like this. So you have your vector, you have a number followed by I, which means that this I is just like x coordinate plus or minus a number followed by j. J means y coordinate plus a number followed by your k, z coordinate. Now this is positional vector. Now let's learn free vector. Now let's look at this diagram here. This is v. Now if you observe it closely, it has a starting point here, it has an ending point here. At the ending point, we have an arrow head here. We have this, so which means that the length represents the magnitude, the orientation represents the direction. Now the ending point is what we call head. In Yoruba language, we call it ori. So the arrow head, we have head, we call it the head. That is showing you the point of action. Now we have the tail. This is the tail, the beginning, the tail, iru. Ori, iru. Now, what about the direction of this vector? The direction is taken from the horizontal plane, moving anti-clockwise. Now, when you read the angle, this is the direction of that vector, theta. Now, this is a vector v. Now, this is also v because they are parallel. Now, what about minus v? A vector that is opposite to this vector and having the same magnitude. So you are going to change the direction of the arrow. So this is minus v. If this is v, this one is going to be minus v. Understand this. So if this is 40 Newton, this one is going to be 40 Newton in magnitude, but the direction will be different. That is what I'm showing you.
When it comes to equal vector, we say that two vectors are the same, are equal when they have the same magnitude and the same direction. So which means equal magnitude, same direction. Now, this is just the introductory class to vector. In my subsequent video, we are going to start properly. Now, what have we learned so far? We discussed about scalar, that scalars are quantities that only has values. So the defining thing about scalars is their value. So you are not using any other things to define them. E.g., we talked about distance, we talked about energy, we talked about power, and the likes. Now we have vector. Vectors are quantities that has both the magnitude and the direction. Magnitude and direction are the defining things when it comes to vector. Now, what's the meaning of magnitude? Magnitude simply means size, numerical value. Size and numerical value. Now, we talked about different types of vector. We have free vector that we liken to polar coordinates. We have positional vector, we liken it to Cartesian coordinates. Now, we talked about free vector, that a free vector is going to have an edge, the terminal point. Is going to have the tail, the beginning, the head being the what? The terminal point, the tail being the what? The origin. Now, a free vector is going to have a direction, which means you are measuring the angle using your x coordinates. Starting from x coordinates, moving anti-clockwise. We also talked about difference between speed and velocity. Speed is a scalar, velocity is a vector, distance is a scalar, displacement is a vector. Now, thank you for watching this video thus far. So if you haven't subscribed to my channel, kindly subscribe to my channel. Click on the notification icon to get notified when I release the next video. Comment your view about this video. Just comment. Thank you, share and like. See you in the next video. Bye for now.